Hello, seventh graders. Today we are going to do this speed reading task, which as a task means I'm going to read some stuff to you and then you are going to pause me and you are going to try it out. Here we go. Let's see what it says. And there we are. Speed reading task. You need to know Monica can read 7.5 pages in 10 minutes. The M got cut off there, but that's minutes. Brendan can read 12 pages in 16 minutes. Here's the part I want you to focus on first. Who is the faster reader and how do you know? Use some kind of mathematical reasoning to support your answer. That means don't just write Monica, don't just write Brendan. Make sure you verify for me how in the world you know who is the faster reader. So right now you are going to pause me and figure that out. All right, perhaps you tried one of these ways, and I find that after what we've worked on in math class, students proved to me in this instance that they do have some prior knowledge that helps them here, and that's called unit rates. So a lot of students recognize that it's hard to make comparisons when we're out of different measurements, like this one's measured in 10 minutes and this one's measured in 12 minutes. So many students, because we talked so much about time being on the bottom, many students will work it this way, where they say, okay, Monica is 7.5 pages in 10 minutes, or 7.5, you could leave it as a fraction. I just changed things to decimals because it's a little easier to type in. And Brendan is 12 pages in 16 minutes. So when I do that division, here's what's really important. If you did it in this order, that's just fine. But make sure that your words make sense to what's going on in the scenario. That means Monica reads 0.75 or 3/4, if you got a fraction, 3/4 of a page in 1 minute. And look at this. Brendan also reads 3/4 of a page in 1 minute. So this is kind of a trick question. They actually read at the same exact rate. And even if you did, some students did it the other way, or even if they set up their rate instead of pages over minutes, some students set up their rate as minutes to pages. That's just fine as well, because look at what happens. Now, it looks like we're getting a different answer, and we are, but that's because this answer has a different meaning now. So if this is 10 minutes to 7.5 pages, and I divide like that, 16 minutes to 12 pages, this 1.3 repeating, by the way, this is 3/4, and this is 4/3. It just flipped over. This 1.3 repeating tells you how many minutes it takes Monica to read one page. So this over here is how many pages she can read in 1 minute. This is how many minutes it takes to read one page. But still, it's the same rate. 1.3333, that's 1 1/3 minutes per page, 1 1/3 minutes per page. They read at the same rate. That's what they mean. That's what that means, okay? Monica and Brendan read at the exact same rate. Now, we used a unit rate to help us find that. Let's check out part B. This says the same information again. This is not new information. If Monica can read 7.5 pages in 10 minutes, that's the same thing it's set up here. So I'm not changing that. That still means 0.75 pages per minute. If Monica can read 7.5 pages in 10 minutes, how many pages can she read in 20 minutes? How many pages can she read in 1 hour? So that's actually 2 questions for you. If she can do 7.5 pages in 10 minutes, how many pages can she read in 20 minutes? How many pages can she read in 1 hour? Once again, you are going to pause me and try to figure this out. Where does it go? Pause me. This is one of the first things that I often see students try, and maybe you tried this as well. It's a good strategy on this. If she can read, it's the equivalent ratios, trying to come up with equivalent ratios. If she can read 7.5 pages in 10 minutes, what would that be in 20 minutes? And what would that be in 60 minutes? And many students recognize, and maybe you did this too, many students recognize that to get from 10 to 20, all I have to do is double it. So if I do that with the minutes, I could also do that with the pages. And 7.5 times 2 would be 15 pages in 20 minutes. And that would make an equivalent ratio to 7.5 pages in 10 minutes. So if she can do 7.5 pages in 10 minutes, she can do 15 pages in 20 minutes. And then they realized that to get from this ratio to this one, instead of timesing by 2 to get from there to there, we can times by 6, which means we can do the same thing to get from there to there and times by 6 and get another equivalent ratio that is 7.5 times 6, which is 45. So I could do 45 pages in 60 minutes. And some of you might be saying, Ms. McGowan, I didn't times that by 6. I just went, well, to get from 20 to 60, I times by 3, so 15 times 3. And you're absolutely right. And the reason all of that is working is because these are all equivalent ratios. They're all equivalent ratios. Now, here's the deal though. I'm going to show you one more way over here, but before I do, I'm going to show you why we need another way. Because check out part C. Part C says if Brendan can read 12 pages in 16 minutes, how long will it take him to read 37.5 pages? How long will it take him to read 90 pages? Okay, so in this instance, I know this already, the 12 pages in 16 minutes. But this is getting complicated now because now I'm trying to figure out what is it in 37.5 minutes. Well, that's definitely more complicated because that's not, these were nice and worked out just fine because 10 went to 20 and 20 went to 60 and those are all fine. 10 went to 60 and that worked out fine. 16 to 37.5, that's getting a little strange. So let's come back up to part B, because I know some of you are dying to tell me that you tried this a different way. Can you use the unit rates up here to help you with this? Isn't it true? Let's go with this one. Isn't it true that this is this type of scenario? Isn't that just a K value? And if there is a K, can't we say, oh, y equals 0.75x? We're about to learn here, right now, why we did so much with these equations, what these equations can actually do for us. Because here's the other thing that I know. I know that if I did pages per minute, and minute was on the bottom, that means x is minutes, and y is pages, right? You guys with me right now? So that's because my ordered pair would have been, I could have had an ordered pair written here where I said, okay, the ordered pair that you gave me, pages is y. I could say it was 10, 7.5 for Monica, and that turned into 7.5 over 10, right? Because k equals y over x. That should all sound familiar to you. Now, here's what I can do, and this is a little bit trickier. It's also a lot more algebraic. Nice and algebraic. We love algebra. So when I do this, I am going to say, okay, I'm looking for 20 minutes. Well, is minutes the x or is minutes the y? Minutes is the x. So what I can do is I can take this equation and look at this. I can just plug 20 into the equation. And then I do 0.75. Let's check that out. What's 0.75 times 20? Well, of course, it's 15. That's what we got with equivalent ratios. But now we found it. I had x, the minutes, and I just found y, the pages. Here's the beautiful thing about the equation is I can plug in whatever I want. I can now plug in 1 hour or 60 minutes. Okay? And 0.75 times 60 is, of course, 45 pages. Having the equation is really, really helpful because then I don't have to worry about whether it works nicely with equivalent ratios. Everything will work. So on part C, his 12 pages to 0.75, I know he read at the same rate as Monica. So what if I immediately go like this? What if I say K is 0.75, Y is 0.75X, the variables are going to be defined the same way, same unit rate. X is minutes. Should you write all this down? Y is pages. So that's all defined the same way. And now I can take this equation and I can plug in whatever they ask for, which the first thing they ask for is 37.5. Oh my goodness. 37.5. Not only that, but they gave me pages instead of minutes. Tricky. Do you know what that means? That means I need to change this because they gave me y. Huh. That means I'm going to plug it in right here, and we got to get back to some of our solving equation skills. You ready? I'm going to put this in for y. 37.5 equals. Why did I put it in for y? Because y is pages, and they told me pages. Pages is y. Y is pages, so I put it in for y. Equals 0.75x. Now, here's what that means. How do I solve for x? We've done this a bunch of times, you guys. I have to solve by dividing both sides by 0.75. When they give you x, you can just plug it in and multiply. When they give you y, you gotta work backwards. Okay, so I'm gonna type this in here. I'm gonna do 37.5 divided by 0.75, 50. Now, what did I just find this time? I found x. So that first answer is 50 minutes. And then, answer. And then I am also going to do, how long will it take him to read 90 pages? Plug it in for y, divide by 0.75, divide by 0.75. 90 divided by 0.75 is 120 minutes. The beautiful thing about finding a unit rate and making an equation is that then you can plug it in and find whatever you want, even if the ratios don't turn out nice and equivalent. So what is K? Let's fill in some answers here. K is the unit rate. Also, the constant of proportionality. Remember that? Big fancy language. It's the unit rate, constant of proportionality. Finding K in a table or a graph is still y over x. So it's very important that you have those variables defined. And using K in an equation is y equals kx. We're still going to use all of those skills to help us solve problems.